So the next presenter will be in the session will be Zsolt Palatinus, who is also associated with CESPA, University of Connecticut. So he got his PhD in CESPA in 2013. He's assistant professor of psychology at University of Szeged at the Department of Cognitive Neuroscience. His research focus multi-skill interactions in perception, action, and cognition, physiological measurements as precursors of cognitive changes, such as aesthetic experience. As a member of a research team of psychologists and economists, he just won an innovation prize for new methods in measuring technology acceptance in self-driving cars. So I have to disentangle my presentation somehow.
It's on the bottom of your screen, Andre.
Bottom of the screen.
Yeah.
I'm sorry. Over the screen.
Top.
I don't find it.
The top.
Gosh. Okay.
Stop.
Share screen or
Okay.
okay.
Are we good?
Yeah, ready.
Yes.
Okay. Good. Thank you very much for including me in the program again. So what I like to it's a pretty frightening, I assume, especially at this point in time, it's a pretty frightening title, grounding robot ethics in laws-based behavior control. So let me start with a little, let me ease us into this. So first of all, there's a lot of things that you have to admire AI research and robotics. And then one of the things that I really admire is that they have this tendency of coming up with a set of challenges so frequently and so clearly. Like, I look at this, okay, these are the main challenges in robotics. And I wish we had the same in psychology from time to time, but if we try to do this, we wouldn't be able to agree on what are the main challenges. So this is really something that I like to look at, and also when we talk about the life world and the Husserlian idea of grounding, acting in the experience of living in the world, then I see that it's a good starting point, because many of these challenges, most of these challenges, have to do something with being engaged or being embedded in an environment. And then one has to notice that right from the beginning, almost everything that philosophers on, like, phenomenologists say, that normally for somebody on a natural science part or the computation side, that most of the time sounds like whatever you're talking about is on the wrong side of the objective subjective dichotomy, the side that I normally don't go to, and then the reason that Andre decided that it would be good to bring in psychology, because psychology has this, actually the whole discipline started out as an attempt to find lawful and not just like second rate, but like real first principled lawful aspects of behavior. And then we believe that the knowledge that this can, if psychology is capable of following through that premise, then it would help the enterprise of AI and robotics immensely. So I don't want to frustrate anyone with these images, but basically there's this well-known thing that when you go to science fiction, right from the beginning of robots in science fiction to this very day. We don't have a problem with being in the life world. Like robots in science fiction, they're perfectly embedded, and if they are clumsy, their clumsiness is nuanced. That's not really the issue. They can merrily go to to tackle like the hardest problems of ethics and philosophy, and without actually being worried about not being embedded or or not being within the life world. And obviously it's not the case in many cases, and people like to make fun of that. It's not a nice thing, because I think what we see in robotics, especially in the past 2 decades, is really fantastic. But people like to sometimes make fun of that, their clumsiness. And then for the answer, like from an expert like Pedro Domingos said in a book a couple of years ago that people worry too much about that computers are going to get too smart. Actually, the real problem is that they're not so smart, and they're still, they're going to take over the world. But so what I was trying to, the topic that I'd like to talk about is this distinction between law-based approach. What does it mean to have a laws-based approach, as opposed to have like a rule-based approach? And normally within the realm of ecological sciences or ecological psychology, we tend to draw these distinctions that when you go for a rules-based approach, then you start with variables from physics like amplitude, frequency, complexity, length, acceleration, those kinds of the variables, and then since you're talking about physics, then you imply that there's natural law behind these variables. But these variables by themselves are not, they don't mean anything. Amplitude and frequency, they're absolutely meaningless. So when you take this approach, then meaning at some point it has to be added to the picture, and then it comes with at some point it may come with a terrible price. And then you start dealing with the sensitivity of the organs and the sensors, and again you're back with these very basic variables. And then whether you're going to have any goals that is going to be somewhere down the road, and your models in many cases going to be very limited in extremes, and then it's difficult to leave the lab, difficult to leave like these pre-manufactured environments with these systems. And then people tend to focus on how they're not faithful. There's a slippage between the world and these rule-based, symbolic-based systems knowing of it. And then basically the problem of perception becomes a process of recovering, building it, putting it together, and giving it meaning. And as opposed to this, a laws-based approach would be something that is that in which case natural laws and the laws are not implied, not only implied, but they are looking at physical properties that are lawfully related to action. So physical properties that have immediate action consequences, and then you have meaning from the start. You can start worrying about the sensitivity of the organism, and then as opposed to having like an intensity measurement device to get-go, you have a perceiving acting system to begin with, which is goal directed from the start. And instead of worrying about whether it's faithful or not, you can start worrying about whether it's useful or not. And then you can discover specificity between the world and us knowing it. And most of the time, if you find these kinds of measures, it's going to be computationally cheaper and easier, and perception becomes a process of registering meaningful structure. So here's a very basic example of change being primary. Again, your question is, for your robot, is that rectangular contour in front of me an open or shut door, which obviously has action consequences, whether it's an open or shut door. When you have a rules-based, symbolic-based approach, then you start looking at features that only relate statistically, but you can choose a laws-based approach when you start generating structure lawfully, when you start moving towards that opening. Then you can either have an overall optical expansion, as you see on the left-hand side, or you can have two nested flow fields. The expansion, the rate of the expansion is going to differ from the forefront and from stuff that is behind an open door, so that you can have, instead of gathering a lot of variables, you can have readily and available information on that. And then people early on with these measurements, there's a long list of actions: navigating to a target, following or leading something, catching a ball, avoiding being hit or avoiding being caught, avoiding collision, making contact without collision, like stopping and like having like a gentle connection, just like the one that you would expect when you're trying to land a helicopter, or you're a dragonfly and try to land on something. So all these things all these actions can be approached from a rule-based perspective, and then you have this, the all sorts of information that, like you have it on the top of the right-hand side, you can have all these information, and then you use that information to start building 3D models, and then based on those 3D models, you can start, planning your actions and stuff. And instead of that, the alternative would be to use that information, when you have the right kind of control laws, then you have, again, physical variables that have immediate action consequences. Then you can have these. And then if you look at this literature, you can find a lot of these, available, like, looking at the focus of expansion. And so basically, there's a collection of things, like a collection of actions that you can follow, and then you can find. And then again, it's not necessarily the point that I'm trying to make is not necessarily that we have to put together a rules-based approach with a laws-based approach and then decide which one is better. It's more like, once you have a laws-based approach as being primary, then you can have your rules derived from that. And you can have like rules like, okay, if you want to reach the target, then you keep the target within the focus of expansion. If you want to catch a fly ball, then you have to position yourself in such a way that you cancel out optical acceleration in both directions. And then if you follow those rules, because those rules are built upon ecological laws and laws for that is relevant for they have action consequences, then you can set out and imply or implement these rules. So it's more like what I'm trying to tell you is not like it's either or, but if you have primarily you have the ecological laws, then it's going to be easier to set up rules. And it's true with today's self-driving technologies. With these cars, you have to be able, as our first speaker Tim was trying to say, that when the context changes, like you're moving from a motorway, or you're moving from an area of a motorway, then you're driving alone, to another area where there are lots of other actors, then the context changes, and then the set of actions that you're supposed to do also changes with that. So but behind this, there's really like an overall idea of you have a problem and then you can start detecting physical variables that have action consequences and then use those to set the action parameters. And then if you look at this literature in ecological optics, you have vision, you have ecological acoustics, you have the sense of touch, you have scent detection, and then a large collection of these variables and these relationships. So basically, and the promise of this is that the behavioral settings and the types of appropriate actions could have been selected in a self-evident and lawful manner. And that really may lead us to, apart from, as it was earlier, pointed out that, okay, these things might be useful in, in basic locomotion or, basic actions, but, how do you tackle problems when you have social action, and then when you have actors with elaborate, cognitive capabilities. And then from an ecological point of view, really the message is that those things are not going to be terribly different. So, again, on this particular slide, you see the rules-based approach on top that, you can have. This is a pretty standard way of going about, business. You have picture recognition, you have, picture or video analysis, and then you have recognition modules somewhere when you have a lot of, pre-saved or a large library of actions, and that's how robots are going to recognize action and then start planning out their own actions. When in fact, it doesn't matter how socially complex an environment is, it still makes sense. And people, already looking at like pretty, I would say, normally, you would say that those are pretty, high level cognitive assessments on, understanding and deciphering involvement or recognition of problems, but they still have action parameters. They still have law-based circumstances where you can start, looking at those things. And it's not the best example that I found, but I really see at the beginning of this, social robot in the picture on the bottom, where you find that there's a kind of an unwieldy rubber sheet that the robot is trying to help the human. This is from MIT, and then the robot is trying to select the right kind of variables. And one of these variables that they find really useful is to focus on the biceps of the human. They're looking at that. Okay, so how the whole thing is going to unfold, following and keeping track on the variables that have to do with the goal and how to achieve that goal is a useful source of information. So basically, what I was trying to say is that in many cases, acting and being embedded in the life world may appear as a really difficult task for robotics, but in many cases, that difficulty or that complicated nature of the thing could be a consequence of mostly following a rule-based approach and then having the idea that because I'm looking at physical variables, then I'm actually related to natural laws somehow, and implying that because I'm working with intensity measures and working on amplitudes and frequencies and all kinds of, then basically I'm on the natural law side, where in fact you could start with the kind of laws that have behavioral consequences and action consequences, and then base the rules for the robots on those laws. And then this idea of there's an ecological physics is actually formulated to handle the word agent as a unit. And we already have a large collection of action and actor relevant laws. And then at some point, and that's really something that's it's a speculation side of this, but I would not be surprised if you follow through these things, then it turns out that ethical aspects of behavior, like ethical aspects of being on the road or being in a conversation or being in a setting, then there are humans and children and robots and all these actors are involved. Then there are ethical aspects of what is appropriate action and what is not appropriate action. And then those will have also detectable, lawfully generated physical features. So those features, if we study them and if we find them, then they can also be useful in controlling actions. So, and with my students, actually, we're already started on looking at immersion, emotional involvement in technologies and also in aesthetics. And then what I can report so far is that this approach is promising. There are, trustworthy relationships and reliable relationships when it comes to choosing appropriate action and then recognizing a change from one set of how the context changes. There are actually measurements that can predict those kinds of changes. So I think it's very well worth, this whole body of literature is well worth looking at and see how it's relevant to the problems that you might have on hand. And I thank you very much for including me in the program again.
Thank you. Well, that was probably more challenging and more difficult presentation, but I think you did a good job time-wise and content-wise. But let's see how other colleagues think. Any questions? Open to questions. Probably you may have. No? So everybody agrees with this contrast and the fundamental problem in robotics, obsession or the primacy of rules and the states and physical variables, objective measures, and so on and so on.